Let's round out a few more problems dealing with inverse trig functions before we get to differentiation. The first thing we want to do is we want to take sine of arc cosine of 1/2. So there's a couple ways to do this. One is to recognize some unit circle values. The other is to construct a triangle. So let's take a look at this one using unit circle values. What we know is that if y is arc cosine of 1/2, then cosine of y is 1/2. And remember, we have to restrict the y values here to negative pi over 2 to positive pi over 2. Now, in this particular case, or really should be 0 to pi, right? That's odd. Sorry, I'm sort of talking out loud here. So in cosine of y equals 1/2, what we know is that what unit circle value would give me 1/2? And if you remember your unit circle well enough, you know that the answer is pi over 3. So y is pi over 3. So then what I have to do is I have to say this is sine of this, so that's pi over 3. Because that's the whole point. We were evaluating what that y is. So these two things are equivalent. Sine of pi over 3 is square root of 3 over 2. Okay, simple enough. Units using unit circle. But what happens in the case where we can't use the unit circle? What if we say, all right, tangent of arc sine of 4/5? So in this case, I have to say y is arc sine of 4/5, so sine of y is 4/5. And so there's not a unit circle value that gives me sine of y equals 4 over 5. So what I need to do is I need to construct a triangle. I have to say y is here, and this is opposite over hypotenuse. So the opposite side is 4, the hypotenuse is 5. And if you remember your old school Pythagorean triples, you know this is a 3, 4, 5 triangle. But if you didn't know that, you could use the Pythagorean theorem to develop the idea that that's a 3. So this is a 3, 4, 5 triangle. So what I need to do is I need to evaluate the tangent of, since this is y here, I need to get the tangent of y. But tangent is opposite over adjacent. So that gives us 4/3 for the answer, which is, you could have done this problem exactly the same way. You just would have had to develop a 30, 60, 90 triangle is what would have happened there. But so there's two ways to evaluate it. Pick whichever one you want. This one will work for any input. This one really only works if you know the unit circle values. So finally what we have is a case where we're going to use that inverse property to solve for what x is. What happens here is we've constructed some sort of expression that, maybe this is a model of a system. You say, okay, the model works like this. How do I get x by itself? So what we're going to do is we're going to leverage the inverse properties to see if we can do that. So arc sine of x plus 2 is equal to negative 1/2. So let's use the cancellation properties. Let's say we say sine of arc sine of x plus 2 equals sine of negative 1/2. But sine and arc sine are inverses. So x plus 2 is equal to sine of negative 1/2. Now we have to be careful because sine and arc sine are inverses, but there's a restricted domain and things like that. So if you were doing this in sort of a real world scenario, you would need to make sure that you don't end up with values that don't make sense for your original expression. So just sort of something to be aware of, that you don't want to plug in something that's going to cause the arc sine to just fail because of the domain. Now, in this particular case, I say x plus 2 plus sine is equal to sine of negative 1/2 to get x by itself. I get negative 2 minus sine of negative 1/2. And what you'll find is that that's perfectly fine. That satisfies that expression, no issues. Because when I plug all that in, it ends up resolving to like sine, negative sine, oh, it ends up resolving like sine of 1/2, which is a perfectly valid input for the arcsine function. So you're good to go here. And realistically, for any of these, just solve it through, but make sure to always run it back through the original problem and make sure that it satisfies the conditions.